Now let's get started with the question number 6. The question number 6 is about this shaded region. So what we can say about the shaded region is it's a helicopter landing pad, and the area is a major sector AOC, a major sector, and this is the center. Okay, and we can say this distance, if it is r, this distance is also r because that's the radius. They have given OA to OB, which is 15 meters, and they already gave the BC, which is 2 meters as well. Okay, there are a lot of information given. This distance is also given, which is 2 meters. CBO is okay, it's a straight line. Angle CACO. ACO is 0.6 radians. So if we check ACO, so the angle would be this, which would give us 0.6 radian. Okay. So we have a lot of information. Let's see, show that the angle COA. COA, they're asking about this angle. Let's put a X there. Okay, so how do we get that angle? The very first question is that. So what is the relationship that we can take for the angle COA? This is our question. COA. Okay, by looking at this, what we can say is, we know we can use the sine rule. So if we take about, if I quickly, plot this triangle here. Okay, so we know the triangle is like this. This is a bit longer, so which is, this one is 15. This one is actually 15 plus 2, so altogether it will be 17 meters, and this is the x we need to know. And we know this information, which is 0.6. So we know by sine rule, this angle will correspond to this side, and this angle would corresponding to this side, and if I take this angle will corresponding to this side. This is how we have it. And also if I put the variable, it's ACO. A is here. Okay, this is the values that we have by now. Okay, by the sine rule, so whenever we are writing the answers, we need to write what theory we are using. By sine rule, what we can see is the side AC divided by sine x equals CO divided by this angle. Actually, literally we can actually get that angle too, but let's put it for theta for now. But we know what the theta is. Sine theta equals OA divided by sine 0.6. Okay, let's grab the information that we know. We know OA and the OC. So we can erase these answers because since we know the numbers, we can write this thing is going to be 15 and this thing is going to be 17. So with this information, we can say it easily can be found the sine theta. So we know when you do the cross multiplication, 17 times sine 0.6 equals sine theta times this. When you get the 15 to the other side back, you're going to get this. So theta will be the sine inverse of this value. So when you get the sine inverse of this one, you will get the answer as 0.694. Okay, so if we know this, in a triangle, the three of them adds up to 180. So which is pi equals 0.6 plus 0.694 plus x. So x would be pi minus 0.6 minus 0.694. So you can easily get it. Pi is going to be 1.847. But here let's see how many significant figures or something they're asking for. It's 3 decimal places. Yeah, so we can finish it here. Actually, whenever we have a 3 decimal places, let's make sure that you go for that approximated value. So this is the radius. And let's say they are asking us, yes, they are also showing us to show this value. So this guarantees that whatever the answer we got is correct. And the next one is the total area of the helicopter. Okay, so they need the total area. So the theory wise, it's a triangle and a sector in radians. So we know if we want to get the area of a sector, we know how to get it, which is quite easy, which we can say it's going to be half r squared theta. Right, and also for the triangle. So anyway, come back to triangle later. Here it's half into radius was 15 squared and theta. Okay, theta is this value, which is we know 2 pi minus x. So we know it's going to be 2 pi minus 1.847. So we can easily get the answer there. So which we have 499.0. So is there any significant figures? Yeah, they're asking for 3 significant figures. So you can, okay, that's for the final answer. So let this be at this level because you have to find the triangle also because it's just this sector part. Okay, let's go to the triangle. For a triangle also we have a common rule. Area of a triangle. What we have is half BC sine A. So according to that, we know the B and C, so we need the x in the middle. So it's half into 15 into 17 into sine 1.847. So actually in such questions, they are giving you the COE angle like this in the first part so that you can use it for consecutive values if something goes off. Okay, this one would be 122.7. So the total area is literally the addition of both of them. It's going to be 499.0 plus 122.7. It's 121.7. But when you get for like a 3 significant figures, you get it as this value. Okay. And then they're asking us, what is the perimeter here? So they're just asking the perimeter. Perimeter is the outside length. So if we take it, it should be this arc. You can get this arc, and also you can get this side, and you can also get this 2. 2 is quite easy. It's just that we need to get the CE as well. We actually, to get the CA, we have the thing here too. Okay, let's do one by one. Let's do the perimeter in here in a fresh page. So we can see perimeter equals arc length plus 2 plus, so now arc length plus 2 plus AC. So with the sine rule, we know we can write AC sine x 0. Sorry, not 0. 0.6 divided by, I'm like, side in front, so which is 15 divided by sine 0.6. So AC would be 15 sine 0.6 times it by sine 1.847. So we get the AC as that. So that's a pretty straightforward part. You can easily get the AC value. So it's gonna be 25.55 meters. Okay, actually there's a one more way that you can do for the AC length, which is cos theorem. By cosine, we know we can get the AC squared equals, if it is AC, we're gonna get this squared plus this squared minus 2 of that 2 and the internal angle. So we can easily get like that as well, which is 15 squared plus 17 squared minus 2 times 15 times 17 times cos x. AC would be root of this value. That also will give you 25.55. So I'll keep these values for you, but it's just a different method if you want to. Okay, now let's go. Just finding the AC doesn't help us. We need to get the arc length as well. Arc length is pretty straightforward because there's a direct formula for arc length. For arc length you can take it like it is pretty easy. That's gonna be r theta. In your case it's 15 2 pi minus 1.847, which is easily can be taken, quite straightforward. That will be 66.54 meters. Okay, so let's put our numbers here. Arc length is 66.54 plus 2 plus 25.55. So that's how we usually do. So that will give you how many decimal places they're asking for. They're asking for three significant figures. Okay, so the answer is coming like 94.09. But we know for three significant figures, it will be this 94.1 meters. Yeah, this is how we get that. So let me take this into like a, I would say for a smaller version. Otherwise it's too unclear. Okay. Yeah, thank you. That actually fills up the whole question. Thank you.